All right. Now, in the past, what I've done in this course is I only went over synthetic division, but based on my experience teaching this, it seems that people have encountered polynomial long division. Now, I know I have said that I'm not going to assume, but no, what I'm trying to say is I'm going to teach polynomial long division. I will do that. If you haven't seen long division before, polynomial long division, that's okay. But I figured it'd be good to go through that instead of just synthetic division. Okay, so assume we have capital F of x divided by capital D of x. Okay, let's just suppose that. Then, okay, where D of x again is non-zero, right? To do polynomial long division, just like with numbers, you want to set up this kind of thing, notation. So the dividend is under this, got what this is called. Over here, we have the divisor. You know, if you have f of x over d of x, here's the numerator, here's the denominator. Okay, as you can see. A lot of these notes, I put the website down where I got the notes here from. I mean, I wrote the notes, I wrote these notes, of course, but I used the stuff on this website to help. You know, you could check out the website if you want, so it's free to see. I think it's a community college website, if I remember correctly. Anyway, so now that we have this, we can see the process for polynomial long division. I mean, you want to make sure each polynomial is in standard form. Again, what that means is, as you go from left to right, the exponents of the variable, x, they're decreasing. And if you're missing any terms in a polynomial, right, after the leading term, you can use zeros to fill in the missing terms, kind of like almost like placeholders. In fact, you actually have to do that here. Then what you do next is you divide the leading term of the dividend by the leading term of the divisor. So the leading term of what's in here, you're going to divide it by the leading term of this. What you're going to do, the answer you get, you're going to put it over the dividend, just like with real number division. You're going to put it over the dividend, over its like term. Okay? And then you just multiply, right, the answer by the divisor, and you're going to subtract that from the dividend and bring down the next term. Okay, again, it's just like with real number long division of numbers, that's better. And here, if the degree of the difference is less than the degree of the divisor, or if you get 0, okay, then you're done. That difference is the remainder, you stop. But if the degree is not less than that, or if you don't have 0, then you have to repeat the process. Okay. All right. We'll do some examples. I know this is kind of intimidating, but again, let's do some examples. So basically the notation here I'm illustrating is this. You're going to divide. Here your quotient's going to be, and your remainder is going to be down here after a bunch of steps possibly. And once you get those, you can write it like this, as in the division algorithm. And again, this is equivalent to this. I mean, essentially, you just multiply both sides of this by d of x, and you get this. D of x is not identically 0, so it makes sense to do this. All right. Moving on. Okay, so let's do an example now. Let's say we want to let's let f of x be this thing. and d of x be this. So so this is our dividend. This is our divisor. Notice they're both already in standard form, right? As I wrote down here. And notice also they're not missing any terms, right? Every term after the x cubed term is accounted for. You know, you're not missing an x squared term, you're not missing an x term, and so on. Same thing with d of x. So this is our dividend. This is our divisor, as you can see. Okay. Again, as I said, they're both already in standard form, which is good. And they both are not missing, and neither one is missing any terms. Okay, so from here, right, we divide the leading term of the dividend by the leading term of the divisor. So we have 9x cubed over 3x squared. And remember, when you divide monomials like this, you divide coefficients. 9 over 3 is 3. X cubed over x squared. You subtract the exponents of the variable. So in this case, we're going to get 3x. Now 3x, we're going to put it up here, right, over its like term. 3x, the like term of it is minus 2x, so that's over 2. So that's why I put it here. Now, what do we do next? We subtract, we multiply 3x with the divisor. Then we subtract it. 3x minus 3x squared, that's 9x cubed. 3x times 5x, that's 15x squared. 3x minus 1 is minus 3x. And we subtract that. Okay? We subtract it. Now, when I subtract, what I like to do is I like to change this minus into addition and distribute the negative. Let me say it again. I like to distribute the negative and change it to addition. I mean, you really don't have to do that, but I personally like to do that. Right? So when we add these cancel, as you can see, we have 9x squared minus 15x squared, which is, excuse me, plus negative 15x squared, which is minus 6x squared. Minus 2x plus 3x, that's just x. And as I said in the procedure, you bring down the next term. So this is what we have. Now, here, notice the degree of this difference, right? The degree of this difference, excuse me, the degree of this is 2, which is the same as the divisor. What does that tell us? We do the process again. You only stop when this difference has degree less than the degree of the divisor or when it's 0. Okay, so let's repeat. We have minus 6x squared over 3x squared, right? We're repeating the process. And what's that quotient? Minus 2, right? Again, we're dividing leading terms. The quotient is minus 2, right? Minus 6 over 3 is minus 2. X squared over x squared is, you know, they cancel. So minus 2 we put here over its like term, as you can see. So what happens next? We have minus 2 times this here, as you can see. So we have minus 2 times this product, which is on the next slide, down here. Minus 2 times this product, right? And we subtract the difference. Subtract the product, excuse me. Okay, that's good. And again, what I like to do is distribute the negative, and then you change it to addition. Minus times minus is positive, right? Minus times minus is positive. Minus times positive is negative. That's why we have this. You know, I put the plus here just to remind myself we're adding. So we add, these cancel. 10x and 10x is 11x. 5 minus 2 is 3. So that's what we get. Okay, that's what we get. Now we actually don't have to divide again, right? And why is that? The degree of this is less than the degree of this. This has degree 1. This is degree 2. So we can stop. What we get then is, actually, let me say it here as well. This is our quotient, 3x minus 2, and our remainder is 11x plus 3. So I just wrote that here. And by the division algorithm, you can write, you know, this is f of x, this is d of x. You can write all this like so. Like so. Which in this case would be this. Or if you want, you can write it this way, and you end up with this. You know, either way. Any questions on that? Okay. All right, moving on now. Let's do another example.